All right, before we start, I did not tell you what page this was going to be. This is going to be page 71 in your notebook, so put a 71 on there, and then you can staple it in there at some point, okay? All right, so now what we're going to do is we are going to be going back to our notes, and we're going to be finishing the right side of the notes today. So let's go through these, and then you will have a handout, and we'll do some through there, and then your job will be to work on that as well. Okay, so again, these notes were on page 76, and let's go through these. So the first thing I'm going to do is simplify. So in a problem like this, I'll be doing some multiplying and dividing because, hold on, I need a calculator. Okay, well, I don't have a calculator in here. I was going to show you something that you could do, but I don't have one. Anyway, so the first thing is divide. I want to look at this fraction as 4 over 32 and realize I could simplify that fraction. So that's what I mean by dividing. I can take a 4 out of both of those and make it 1 over 8. And then my x's, we learned that if they're the same base and they're dividing, that we could subtract the exponents. So when I'm done, I'm going to have 2 x's on top. And then I can do the same here. I'm going to have 6 y's, and because 8 minus 2 is 6. And since there are more y's on the bottom, that's where I'll put the 6 y's. All right, first thing is done. I have simplified it. I remembered my rules of exponents. The dividing is the simplifying. So the next thing is rule number 1, no fractions under the radical. Well, I have a fraction under the radical, so that just means, you know what, separate them out. So that is how you fix this rule, like this. Whoops, sorry. All right, so I'm just going to put that over here, and we talked about this on the front side, that you can just separate them out like this. I'll put little ends here, and that's all we're doing. Instead of one big fraction under there, we have 2 little radicals. All right, the next thing that we're going to do is we're going to make a factor tree. We want everything in prime factorization form. And the only thing you need to make a factor tree of is the coefficient. So 1 is 1. I can't make a factor tree for that, but I'm going to make a factor tree for 8. And it becomes 4 and 2, 2 and 2. So in the end, it's 3 2's. So now I'm just going to rewrite it with that. Okay. So step number 3 is taken care of. I've not changed the problem. It's still worth the exact same amount. So now what we're going to do is we're going to go to step number 4. And we have to deal with rule number 2, which says you cannot have a radical in the denominator. And I do. And we cannot have this. Again, it's a really old rule. I talked about the slide rule. So what we're going to do is this process called rationalize the denominator. And you have done this. We're just going to do it a little differently. So what we're going to do is we're going to build up the denominator. So we're going to build up anything that's not perfect in the denominator so that it's now perfect. And when it's perfect, we can take the stuff out and we won't have a radical under there. And we'll talk about this next. So before we start, I need to talk about how we're going to be building this up. So you don't need to write this down. This is just on a side note. We're going to be multiplying, well, sorry, now write this down. We're going to be multiplying this by a fraction, okay? And when I multiply it by this fraction over here, I can't change how much this fraction is worth. It's got to still be worth the same amount. So I need to make sure that this fraction is worth 1, because 1 times anything is itself. So for instance, if I have 7 on the numerator, then the denominator that would make this fraction be worth 1 is 1. Or if I have the square root of 2 on the bottom, then on the top I would need a square root of 2. Or if I have a third root of 4y on the bottom, then on the top I need the third root of 4y. Okay? All right. So with that, I'm going to be building this up, and I have slowly lost my 4's along the way. I need those. So I will be building this up with the 4th root, because on the other side, I can only multiply a fourth root with another fourth root. So I can't use a cubed root or a square root. That's why I needed those 4 there. So I'll be building up with another fourth root. And I want these 2's to be perfect. And that's what you did on the other page. That's what you did on the pink page. So for instance, these 2's were perfect because 4 went into 4. These were perfect because 4 went into 12. So I need some more z's so that they're perfect. Right now I only have 3 2's. So what I need to do is I need some more 2's over here so that when I put them together, they're perfect. So if I had 4 2's, then they'd be perfect because 4 would go into 4. So I'm going to put one more 2 over here. Okay? And then for the y's, I have 6 of them. And I need more so that all the y's can come out. So if I have 6 here, if I just put 2 more, now I have a total of 8 y's. And those 8 y's can come out. And again, this is a fraction that's worth 1. So my numerator has to match the denominator. Okay? So now what I'm going to do is go on to 4b. I'm going to simplify, which just means, sorry, not spelling simplify right. I'm going to multiply the numerators and multiply the denominators. I'm going to combine them. And we're doing this from this rule over here that says when they're separate, you can just put them under 1 as long as they're the same index. So that's what I'm going to do. So here's my fraction. I'm going to start with the numerator. And 2 to the first and 1. I don't need the 1. I'm just going to put 2 to the first. And x squared and y squared. All going under 1/4 root. And now I'm going to go to the denominator. And I'm going to put my 2's together. Here's 3 of them. Here's 1 of them. So there's 4 of them. And then I'm going to put my y's together. And I've got 8 of them. So that's step 4, and now we're going to go to step 5. Nothing perfect can be under the radical. We're going to take everything out. So hopefully at this point we understand the perfect and the not perfect, and we're going to avoid that step and just take the perfect stuff out immediately, and then we'll worry about the stuff that's in there. So here goes. All right, the start of my answer. Okay. I'm going to start in the numerator. So I want to see what can come out and what can't come out. So is the 2 perfect? No. I only have 1, and I need 4 of them. So starting my 4th root for my answer, that 2 is going to stay in there. Of the x's, I only have 2. They're not perfect. And the y's aren't perfect either, so they're going to stay in there. Then I'm going to go to my denominator, and I'm going to take out the perfect stuff. So as it turns out, these are both perfect. We made them become perfect. So the 2 is going to come out, and the y is going to come out. And now I'll see how many there are. And I'll use the division trick. So 4 goes into 4 1 time. And 4 goes into 8 2 times. And you're done. This is your final answer. You wouldn't typically see the 1 there, but we'll put it there. So with simplifying radicals, you need to follow those 3 rules. And again, the 3 rules are no fractions under a radical. Well, I don't have a fraction under a radical. This is under a radical, so that rule's fixed. Radicals cannot be in the denominator. Well, I don't have a radical in the denominator, so that rule's done. And nothing perfect can be under the radical. We've taken everything perfect out. Everything that's here is not perfect. It has to stay in there. And this is simplified. So is this much better than this? No. I mean, it's still a mess. But technically, this is the best way to have the answer. So what we're going to do is we're going to try a few from the handout. So I'm not sure if Mrs. Lambert has handed it out to you guys already or you need to get it, but it's this page. And it's going to be page 75. And I'm going to have my notes next to me as we go through some of these. So there is a front and a back. What I want you guys to work on is the front. When we see each other next week, we will work on the back. And speaking of next week, your notebooks need to be done, and you need to have that blue page for your perfect roots quiz. You need to know what that is, all right? So just have your notebooks ready when you walk into class on Wednesday. Have them done, because I'll check some of them Wednesday and probably some of them Friday. All right, so we're going to start with the first step. So first we're going to multiply or divide, and we're going to remember the rules of exponents. So these problems are a little different because right now I have a 2 on the outside, so I'm just going to save it for later, okay? And since these are both square roots, I'm going to kind of go back to this rule that says I could put them under 1, like this and then divide them. I'm just not going to put them under 1. I'm just going to do this simplifying and dividing. So I'm going to start with 3/6. I can simplify this into 1/2. And then the k's. I can simplify the k's. If I subtract these exponents, I have 1k left, and it's going to be on top. Okay? So that's rule number 1. So with the way these problems are set up, that no fractions can be under the radical, we won't have to do this step because I don't have a fraction in the radical. These are all separated out like this. And I'm not forgetting the 2. I'm just going to save it for later. So step number 2 is not going to happen here. The next thing I'm going to do is make a factor tree of my coefficients. So my coefficient is 1. If I make a factor tree of that, it's still 1. And if I make a factor tree of 2, it's still 2. So I don't have to do that step in this problem. So the next thing is I have to deal with rule number 2 that says no radicals in the denominator. And I have a radical in the denominator, the square root of 2. So what I'm going to do is build it up so that it's perfect. So here we go. I'm going to build it up. And the only thing I can multiply a square root with is another square root. And right now I have 1, 2. So I'm going to put these little 2's here so we can see this. I have 1, 2. I need more 2's for them to be perfect. So what I'm going to do is add 1 more 2 over here. And then because I need to multiply this fraction by 1, I'll also have the square root of 2 on the top. I'm just not going to put the first power. So now what I'm going to do is I'm going to simplify. I'm going to combine, multiply the numerators, multiply the denominators. So here's the combining. So in the top, remember this, we're looking here, 1 times 2 is 2, and k. And on the bottom, I'm going to rewrite this as 2 squared. All right? And now we're going to deal with the last rule that says nothing may be perfect under the radical. I'm going to take out all the perfect stuff. And I'm not going to do the perfect, not perfect. I'm just going to look at the numerator and then go to the denominator. So put some exponents with them. The 2 is not perfect. They're not enough. It will have to stay in there. The k is not perfect. There's not enough. It will have to stay in there. But this 2 is now perfect. It gets to come out, and when 2 goes into 2, I have 1 left. Now, remember that 2 that I circled? It's coming back. It was on the outside, on the top, so it's out on the outside, on the top. And as it turns out, I can simplify a little more. These 2's can cancel out because they're both on the outside, and I'm left with just the square root of 2k. All right, we're going to try another problem here.